Okay, let's derive the famous bias variance decomposition for squared loss. Just a couple of easy steps. So here's my squared loss for one example. It's t minus y squared. Okay, t is the target value, y is the predicted value. Okay, and I'm going to represent with a bar the average y, the mean y. Right. So let me just add and subtract to this y bar. Okay, so all I did from the left to the right of this equality was subtract y average and add y average. Okay, so this is still the same thing as before. Okay. And now I'm just going to expand the square, right? Thinking of t minus y bar as a, and y bar minus y as b. Okay? So, a plus b squared, right? Here's a squared plus b squared plus 2ab, right? So here it is, right? A squared plus b squared plus 2ab. Okay? Just simple algebra so far. Okay? And now let's just take the expected value of both sides. Remember, these are expectations over random training sets, right? Averaging over all different training sets that you could generate at random. Okay? So now I have on this side the expectation of t minus y squared, right? Which is the expected loss, right? The expected loss is your average loss. Okay? So with any one given training set, you might have a certain value of the loss. This is the average that you would have over a lot of different training sets. Okay? So on the right-hand side, I'm going to have the expectation of t minus y bar squared, right? But I can take out the e. Why is that? And just get t minus y bar squared. Why is that?
They all know.
These two things are both constants, right? T is certainly a constant, right? It's the target value. And y is also a constant independent of the training set because it's the average over all training sets. Okay? So both of these things are constant. Therefore, the expectation of their square difference is just the square difference itself. Okay, everybody agree? Okay, so this is my bias. Right? So this is the definition of bias for squared loss. It's just the target minus the average prediction squared. Or you can think of it as the loss between the target prediction and the average prediction. Okay? Should be fairly intuitive given what we've seen before. Okay? And then, of course, you have your expectation of this term here, right? That expectation has to stay right because the y varies with the training set, and this is the variance. Okay? So the variance is just the expected value of the difference between my average y and my y for a particular data set. Okay? Any questions so far? Right? And finally, this whole part goes away. Why does it go away? Right? What happens when I take the expectation of this? Here's a little, piece of Stats 101 that is useful here. Remember the whole linearity of expectation, right? The expectation of a sum is the sum of the expectations, and the expectation of a constant times a random variable is the constant times the expectation of the random variable, right? So let's look at this and see what's constant and what's changing, right? So 2 is certainly a constant, right? So I could put the e inside it. You agree? Right? By linearity of expectation. T and y bar are also constants, right? We saw that before, right? So I can keep moving the expectation past it, right? So finally what I have is a constant times the expectation of y bar minus y. You agree? Okay, but now again by linearity of expectation, this is the expectation of y bar, right? And what's the expectation of y bar?
Y bar.
Just y bar, right? And what is the expectation of y?
Y bar.
Aha, y bar. And y bar minus y bar is?
0.
This one was hard, right? Could have been a trick question. Right? So that part goes away. And there you have it, right? So this is the famous bias variance decomposition of squared loss. My expected loss is the sum of bias and variance. Right, very nice. We just have these two components that add up. So when you have a certain amount of loss, it could be due to some combination of bias and variance. There might be no bias and all variance, or no variance and all bias, or some amount of each. Okay. So one thing that you might want to do when you're doing regression in practice is measure bias and variance, not just error. Because underneath the error, there could be very different things happening as we just saw. And if instead of measuring error, you measure bias and variance, you actually have a powerful hint about what's really going on. Okay? Questions about this? All right, so the next step